Welcome back to the channel. In today's session, we continue with CompTIA SecurityX CAS-005, focusing on Topic 2.1.1.2, Component Placement and Configuration. This topic explains 6 important components you might encounter in enterprise network security: proxies, reverse proxies, API gateways, taps, collectors, and content delivery networks, also known as CDNs. Let's begin with the proxy server. A proxy acts as a middleman between user devices and the internet. When a user makes a web request, the proxy receives it first, processes it, and then forwards it to the destination server. It then relays a response back to the user. Proxies are commonly used to enforce content filtering policies, monitor employee browsing, cache web content to save bandwidth, and hide internal IP addresses from the public internet. For example, in a corporate environment, all employee web traffic may be routed through a proxy. If an employee tries to access a social media site during work hours, the proxy can block the request based on company policy. It also logs the attempt for auditing purposes. This gives IT administrators full visibility and control over internet usage. Next, let's talk about the reverse proxy. A reverse proxy works in the opposite direction. Instead of protecting users, it protects servers. A reverse proxy sits in front of back-end servers and manages incoming client requests from the internet. It can distribute the traffic across multiple back-end servers, perform SSL termination, and cache frequently requested content to reduce server load. For instance, if you run a website that gets a lot of traffic, a reverse proxy like Nginx or HA proxy can be used to load balance requests between several web servers. This improves performance and availability. It also hides the structure and identity of your internal systems from external users. Moving on, we have the API gateway. As modern applications rely heavily on APIs and microservices, API gateways have become essential. An API gateway is a specialized form of reverse proxy designed to manage and secure API traffic. It handles functions such as authentication, authorization, rate limiting, and request routing. Let's say a mobile app connects to multiple back-end services like payments, profiles, and messaging. An API gateway stands between the mobile app and those services. It checks the validity of tokens, prevents abuse by limiting the number of requests per second, and aggregates responses to simplify communication. A popular example is Amazon's API Gateway service, which works with serverless applications built on AWS. Now let's cover taps, or test access points. Taps are hardware devices used to monitor network traffic passively. Unlike a switch port or router interface that may drop packets under high load, a tap provides a full, unfiltered copy of network traffic. It is placed physically between two devices, like a firewall and a switch, and splits the signal to send one copy to a monitoring tool without affecting the flow of traffic. Security teams often use taps to send real-time traffic data to intrusion detection systems or packet capture tools. Because taps are passive, they do not introduce latency or create a point of failure, making them ideal for forensic analysis and monitoring sensitive segments of the network. Next, let's look at collectors. A collector is a system or agent that gathers logs, telemetry data, and network events from various sources across an organization. This data is sent to a central location, like a security information and event management system, or SIEM. Collectors make it possible to correlate events, detect threats, and generate alerts. For example, firewall logs, server logs, and endpoint logs can all be forwarded to a collector. That collector sends the data to a tool like Splunk or the Yellow stack, where security analysts can monitor for unusual activity, such as unauthorized login attempts or data exfiltration. Collectors are essential for gaining visibility into distributed environments. Finally, let's talk about the Content Delivery Network, or CDN. A CDN is a geographically distributed network of servers that cache and deliver content to users based on their location. CDNs are used to improve performance and availability of web applications, especially for global users. They also provide built-in security features like DDoS protection and web caching. For instance, a video streaming site that serves millions of users worldwide can use a CDN like Cloudflare or Akamai. When a user in India tries to stream a video, the content is delivered from the nearest CDN edge server in that region, instead of traveling all the way from the original server in the United States. This reduces latency and improves the user experience. To summarize, a proxy filters and controls outbound web traffic from users. A reverse proxy manages inbound requests to servers and provides load balancing and security. An API gateway secures and manages traffic between clients and backend APIs. Taps are used to copy network traffic passively for monitoring. Collectors gather logs and network data from across the infrastructure for analysis. CDNs cache and distribute content globally to speed up access and reduce server strain. Each of these components serves a unique role in building a resilient, secure, and scalable architecture. Understanding where and how to deploy them is crucial for both system design and exam preparation. That's it for today's video. If this breakdown helped you understand Topic 2, 1.1.2, be sure to subscribe for more SecurityX content. Let me know in the comments if you've used any of these tools in real-world environments or want a deeper dive into any specific component. Thanks for listening, and as always, stay secure.